Well, thanks for coming, everybody, and thanks to GOTO for having me. I'm really psyched to be here. So I've been working for Oracle for a while. I work in Oracle Cloud now. I came to Oracle as part of the Sun acquisition. I come from a systems background. I was an OS developer, and I wrote drivers and stuff, and started working with containers 6 or 7 years ago, and got into Docker and sort of the whole implementation of what is the DevOps movement, the methodology. I came at it backwards as a provider of technology, building tools. So I've been sort of looking at serverless for about a year and a half. First, sort of with humor, and then with disdain, and then sort of with anger. And now I kind of dig it. So I'd like to share my views with you guys and women. So let me get started. So I said this on a phone call with a friend of mine. So I might have seen Batman like a few dozen times. But this fit, right? She's talking to me about her team not even remotely being interested in talking about serverless, let alone doing proof of concept work, doing a pilot program, because they had just moved from monolith on-prem to containers and Kubernetes, like literally within 6 months. So we're like, no, we're not even talking about that. And this idea of this being a solution that might not only be superior depending on what your context is, but actually it's something that leverages the other work that we've been doing for 5, 6, 7 years, it's sort of frustrating that there's this type of friction. So the goal here is to talk a little bit about that. Because serverless is just the next abstraction, right? So just quick check in the room. Who identifies as a developer? So that's most of you. How about DevOps? And ops or systems people, systems engineers? Okay, just me. All right, cool. So I'm actually a developer, but I built systems. It's complicated. So I think about like, why is there friction here? Why is there this fear? And I don't think I see this much with developers, though these are probably valid things to look at. So why, why is there such a block to adopting this? If it's such awesome, if it's such an awesome thing to build with. And I think that the answer to that lies in not being entirely clear about what serverless offers, and also not fully understanding sort of the liabilities that we have within our own successfully deployed systems. So if we look at abstractions, they've traditionally always been good for computing. They're actually how we advance computing. Tubes, vacuum tubes led to transistors, led to ICs, integrated circuits. This eventually led to like multi-core CPUs. We have CPUs now where like everything's on the die. It's amazing to look at how we've kind of come from literally like moving parts, analog computers, to this in 65 or 70 years. And the same with sort of writing code for computers, right? So we have machine language that led to assembly, led to high-level languages like C, which probably none of you like. And then languages on top of that. And so you can see like we actually build things up from the bottom up with abstractions. So abstractions lower the barrier to entry as well, right? So shown here is the Colossus. This is an old tube computer. And over the years, we refined through abstractions more accessible computing systems, so that you didn't have to be a physicist or know how to work with tubes and gates as an electrical engineer to actually do computering. And in fact, if we needed to still have wire wrap and like soldering skills for computering, we would not have the world we live in today, right? Where everybody can use a computer and everybody can do meaningful work with a computer. But abstraction in systems can feel very uncomfortable. And even for most of the room who you raise your hands as developers, you still interact with systems, right? It might just be an SSH. You might just be running HTOP somewhere to check in, but you're still interacting with systems. And when we start abstracting away even that substrate that you stand on, it can get weird. A lot of our well-worn solutions sort of fall to the side. And I know at least for DevOps and systems people, we can feel sort of like we don't even have a role to play sometimes. So we can start seeing some of the friction, especially in larger teams. So the goals of this talk are to describe serverless as I see it, as both an architecture and a platform, and to share my opinion about the primary benefits of using serverless, and even looking at a serverless first adoption. I want to break down some of these points of friction and offer some guidance around sort of accepting the abstraction. I do want to be clear that this talk started sort of as a takedown. Like I was like, I have this idea where I'm going to say, serverless is the abstraction we deserve, because what did we expect, right? We gave people Kubernetes. What else are they going to do with it, right? So it was like this whole like, yeah, that's what we deserve. But it's actually more of a love letter, really. I do think it is what we deserve, and I think we're ready for it, versus maybe even as recent as 12 months ago or 18 months ago, where people were just not ready to hear about it. So just a little bit of brief history, and I'm sure this will not be news to anyone. Monolithic applications are an anti-pattern, in cloud computing especially. So they're not bad, though. They're not inherently evil. And in fact, monolithic applications is like really easy. You have a blob and you deploy the blob. Like there's very few moving parts. The problem is getting features out the door faster, right? The not a lot of moving parts means you have one blob that has like all 26 of your mission critical business functionality features in it. Yeah, and then bug fixing, getting fixes out. So we know why we've adopted sort of minimized patterns and microservices. And how we did that in a platform is we've evolved from bare metal to using virtual machines, to using containers, to using other people's virtual machines and other people's containers. But the whole idea here is that this stuff came out of a need to actually put features out and bug fixes out faster. And so we end up with what's now, I think, the de facto sort of reference architecture for putting out a set of services to solve a problem, which is using containers with Kubernetes and using a load balancer. You get your database running in the cloud somewhere, a queue maybe. And this is what a lot of people are doing right now. And I hear a lot of people say, oh, it's not like anybody's really using Kubernetes yet. No, it's like half of the Fortune 100 companies are using Kubernetes in production for real meaningful work. But if you look at this, you can see clearly where serverless comes from, right? The only thing in this whole graph that applies directly to your business logic are the things labeled service. So we're deploying code to systems we build in the cloud with containers and Kubernetes, where you might really just want to be deploying code to the cloud. That's what serverless is in 2 slides, right? So now we bring functions to the party in this abstraction thing, and we're building a platform, right, for you to run the functions. Because that's the whole idea of serverless is it's not about writing functions. It's not about adopting microservices and giving them a different name. It's about having a platform where you can give us your code and we'll run it for you, right? That's the real beauty of serverless. And we happen to use functions because it enforces a good pattern. So this is a question I get a lot. And anybody using serverless in the room right now? Okay, maybe like 20%. In production? Excellent. That is exactly what I wanted to see. So for those of you who didn't see, it's about 1/5 of the room's hands went up, and they pretty much stayed up for in prod. Some went down. I think a couple went up after, which is weird, but but that I'll get back to that point. So I hear a lot, what can I build with this? Even as recently as today, I've had like 3 or 4 conversations, which are always really cool because it's always this sort of like, okay, fine. I guess I could look at that, right? Because a lot of people think, oh, it's just for doing the one thing that they've seen somebody do, right? It's just for going through EC2, finding idle instances and killing them. Or it's just for web API backends. Or it's not, it really doesn't work that way. You can build anything with serverless. It doesn't come for free, which we'll talk about, but it's not this sort of boutique niche platform or architecture. It's a whole new way to build software that's very, very portable. So at a high level, This is what a serverless platform looks like under the covers. This is technically most of the stuff you don't care about, right? But you are interacting with things. You're going to decide what event sources, right? So if you have a function that takes an action on a file that's uploaded to an object store, you're going to say, okay, well, when a file hits this object store, fire me an event. That trigger is going to happen, and it's going to run this function, right? You all decide that, because a serverless is an event-driven architecture, and you get to decide like when your code runs. But as far as the triggering and the execution of the function and where we run that and the compute environment and all of that, that is all part of the promise of the platform. So we're talking about an architecture which actually depends upon a specific type of platform. And I think that's something that is obvious when you work with serverless, but until you actually start trying to work with it, even implement a simple test function and upload it, it's not entirely clear that it is that simple. You write some code, you give it to the platform, and the platform runs it when you tell it to. So we've seen this quite a few times. A lot of vendors will show you this. Serverless is a spectrum, right? So on one end of the spectrum, you have full awareness and control of your infrastructure. So we're talking like Kubernetes, or maybe on a smaller scale, Nomad or Swarm running on VMs that you procure, right? You're taking care of that. This is your bespoke cluster environment. And then moving more toward the right, we have container services like Fargate and ECS, Azure Container Service. GCP just put out Cloud Run. These are really neat things. It's basically, you don't have to provision your own VMs. You don't have to build your own cluster. You just say, give me a container, right? And you run a container. Beyond that, right, more toward the right, we have DIY fast, function as a service. So really awesome projects like OpenFast and the FN project and OpenWhisk and a ton of open source projects out there that actually implement functions as a service. And then finally, all the way to the right, you have managed serverless platforms, right? You have AWS Lambda, who was first to the show, and you have Oracle Functions, which was last to the show or latest, and then Google, Azure, Alibaba, everybody, IBM, everybody has their own solution here. And a lot of times, these are actually predicated upon the open source fast projects. So why do we look at the whole spectrum? Right? Because we've abstracted away stuff underneath, and we've brought a new platform to the cloud, which is containers running on Kubernetes, right? Has everybody heard that? That's the new UNIX process model. Look, it's the UNIX process model. Cool, so all of you that raised your hands before as developers, how many are systems developers or systems engineers writing system code? Cool, that's what I thought. So containers are the new process model. Simplifies everything, right? Except it so doesn't. It's actually really quite difficult for, say, a small Java development team with a combined total experience of like 80 years of writing Java code, they're really good at it, to kind of hit this full force and go, yeah, let's Kubernetes, right? Because that's not really within their wheelhouse. And yeah, they can learn, sure, but they have to also do their day job. So this is a problem we see. Now, I quote a lot of people. I'm also going to quote myself. So I'm on Twitter, and if you want random profound thoughts from somebody you don't know, follow me on Twitter. I quote myself. Like, how cool is that? So this came out of a conversation I had the other day, though, and I think it's like worth noting. And a lot of people have said things like this, right? But we conflate the requirements that we have to run a production workload at scale in the cloud with the complexity of the current solutions that we have brought to bear. So because you as a Java developer who's never like bothered with digging into systems because that's not your day job, and you look at Kubernetes or containers and you say that's a totally confusing thing, that's not really truth, right? It's more like it's out of your wheelhouse and you don't really have the time to dig into it. We're all smart people. We can learn whatever we want, but we all have day jobs too, right? So I think it's just important to have this in the back of our heads as we look at sort of what serverless brings and what problems it solves. So what is serverless? So this is like my favorite slide ever because everybody has a different answer. But over the last like 6 months or so, I think we've all decided that there are some bullets that we can absolutely accept. It's probably more like 18 months, but still, depending on what product you're selling or project you're pushing, like these bullets can change. But we all agree that serverless is an event-driven architecture, that it relies on invisible infrastructure. It automatically scales on demand, both up and down, right? So that's really important to note, is that one of the main benefits is that it will scale to 0, right? Event-driven means that your code runs when an event happens that signifies a user trying to do something, a user of your software trying to do something. When they stop trying to do something, we spin it right back down to 0. And you're only billed for execution time, right? So this is pretty cool. And the platform itself is fault tolerant, highly available, and just like any other managed cloud platform you'd expect. So let's abstract these things and say, what does it look like using a serverless platform? So we implement some code and we upload it. We configure a function trigger an event, right? For example, when a file hits this object store, run this code. The platform takes care of running that code, and you only pay for when it's running. So by that duck test, does everybody know what duck typing is, by the way? The duck test, if it looks like a duck and walks like a duck and quacks like a duck, it's a duck. That's what a duck test is. So that, to me, is what we use to duck test serverless. So really, to me, in fact, serverless is not a spectrum starting at Kubernetes and going all the way over. You know, VMs aren't in that picture either, right? Serverless really is the managed platform called serverless that we deploy. And as a practice, it's even more than that. So Ben Kehoe is a great voice in this space. If you don't follow him or read his writing, you should. So he made a really salient point, and I think he's been saying these things for a long time, but he uses a piece of writing that really brought it forward. Serverless is a way to focus on business value. It's not about functions. It's not about a vendor. It's not about automation. It's not about even serverless. It's about the focus that it gives you to focus on business value. So what it is not magic, right? Serverless is a choice. It's an architecture, and it's a platform that we deploy that architecture on. It is super vitally important that we don't think that it's magic. Just like it was super vitally important that we didn't think Docker was magic, right? Does everybody remember that period of time where like everything was going to solve all world's problems, and then it was like, oh, Docker's terrible because it doesn't like compile my firmware, right? It's like, actually Docker can compile your firmware, but like it's a problem that we have in technology adoption, right? Is that we look at what something could be and what we want it to be, and when it doesn't turn out that way, we get real mad at it. Serverless is not magic, but serverless, in the work you have to go through to adopt it, you're going to have to go through that work to really adopt anything. If you have monoliths running on-prem, it's pretty much the same as running monoliths in the cloud. So you're going to have to break things up. And for Greenfield, you're going to have to pay attention to your design anyway, right? So it's not like we're asking extra from you. It's just that it's not going to do it for you for free. So speaking to this, is everybody familiar with Gartner's hype cycle? So this is a really great way to judge kind of like where technology adoption is. So we kind of come to this inflated expectation vista where everything is going to solve all the world's problems, any new technology. And then we fall into that trough of disillusionment and say, oh, it's terrible. It's not going to solve everything. And then we come out of that, and adoption and use hit some plateau of productivity. And we actually start doing good things with the technology. So depending on where you are with serverless, you can kind of be all over the map on this roller coaster, right? I know people that are thinking that it's going to solve all their problems without really doing any work, and they're in trouble. I know people that thought that and are now sitting down at the bottom and crying and sad. And then I also know people that are building, production scale, and running their applications on purely serverless, and have been for years, which is really good to know, right? So we're all over the place here. So the idea right now is to get you through the trough of disillusionment as quickly as possible. And I don't even think there's a way to get to like jump it. Like you're going to be disappointed a little because serverless is so fun at the beginning, and then you're going to hit some problems. The idea is to get through here as quickly as possible to where you're meaningfully productive and you're having a good time. So we keep talking about like architecture and platform. So serverless as a platform and an architecture means that our abstractions are converging. which is really incredible to watch. This is a very big change from just adopting the cloud or just adopting containers. You really are letting go of a lot of your real estate that you have control and influence over. That's something to kind of face head on. Easier maybe for small development teams, not as much for DevOps teams or teams that interact with like an infrastructure team or an ops team. That's where the friction comes in. Pets versus cattle was hard. Like we talked about that for years, and some people still are deploying, fat pets to the cloud, and they're happy doing it, and that's okay. I'm not here to tell them they're wrong, but it's not the best way to scale software, right, in the cloud. Serverless doesn't even care about pets versus cattle. Like those mammals don't exist, right? You just run your code. So Ben Kehoe, again, he says pets versus cattle. In serverless, we think of servers as roaches, which is a little rough because I love systems. But the idea is, of course, you don't care. And letting go, though, is tricky. And again, we really see this a lot in like DevOps teams or teams where someone has a vested interest in making the systems run well. We have to let go of the control that we perceive that we have. And really, anybody that's had a pager and had a great plan for a weekend knows that we don't really have control. Sort of like the laws of nature and physics and humanity are at play here, but we have the appearance of control. And this is even harder if, like my friend, you've come to the cloud recently through a different vector. You've taken your application, which is run on-prem in a monolith for 12 years, and you've broken it up and you've put it in containers on Kubernetes. It's hard to let now that go because you put so much work into it. And frankly, the serverless platform is the mother of all dependencies. I mean, we see like when EC2 goes down, you have this massive outage, right? When serverless goes down, just the whole thing goes away. And so there's some planning that can be done there. And obviously as a platform, it's our job to make sure that doesn't happen. But it is one of those things when you're looking at, adopting this thing, it's just like one big dependency, serverless. So to embrace serverless fully, we have to get rid of some of that control, or maybe all of it. But it's good also to understand where a lot of that control comes from, right? So in my experience, coming from systems, control often comes out of necessity, right? So I can make sure that this fire, if this fire flares up again, I know where it is, and I can get to it, and I can look at it. That's an important thing to me. But the thing to realize a lot of the times is that the fire is a result of the systems that we built, right? And moreover, what then? You have to solve that problem, right? I mean, it's not like because you can stand in the dumpster with the fire, you're better off. Like actually, that's probably not that great, right? And the abstraction acceptance always comes in to play with a context that makes sense for it, right? So it's not like we can't accept the abstraction or we can't drop control. Because when's the last time you talked to a JavaScript developer, or you're a JavaScript developer, who was thinking like how the virtual memory subsystem was implemented? Like we just don't care. Like we just know that the system's gonna run, and maybe it's a little bloaty if you're running Electron, I don't know, whatever. Like it's okay. But under the covers, somebody thought about that and solved those problems, right? So we can accept some amount of abstraction always as a good thing. And the cloud, in fact, is one big fat abstraction. This sticker is just so silly. I always have to put it like anytime this comes up, right? Like there's no cloud, it's just someone else's computer. Lots of computer and storage and networks and on-call teams and just like lots of stuff. There's a cloud, okay, right? But the point is that there's nothing inherently in the cloud that changes how we build and ship software. There just isn't. It's kind of just, using someone else's metal and spinning Rust and saying, okay, we don't have to worry about that. I don't know about you, I enjoyed racking servers. It was fun. Like I loved getting memory upgrades and pulling hardware apart. So I kind of miss that part. I don't even I barely even SSH into machines at this point. I don't even know like what my life's about. So speaking of simple things, let's talk about containers. So I just want to kind of put this down because I think a lot of the serverless platforms are built on containers, and a lot of the serverless users are running away from containers because they're complicated. They're not really, right? Docker solves a lot of problems really elegantly. What Docker can do used to be multiple teams of people that would fight with each other. And now you, as a developer, can just sit on your laptop and like solve those problems. It's pretty cool. But containers don't ultimately solve tons of problems beyond that. To me, containers are sort of a packaging solution, right? More than anything. The fact that they run in a container is really an implementation detail. So it's important that we don't think of containers as the way forward or the thing that solves all of our problems, because they can be used to do that. But it's really an implementation detail of something like microservices. And why do microservices come about? Because we realized CI/CD had to happen. And you can't, really hard to do CI/CD with 1.5 million lines of Java code and 26 features, right? It's just, blah. So we break things down, and that was a convenient place to run those things, but not a requirement. Speaking of simple things, now we talk about Kubernetes. Again, it's not super complicated, and it's really well designed. Kubernetes has incredible abstractions. I don't know if anybody was paying attention to this space, 4 or 5 years ago. There were a lot of solutions for running containers at scale. And it's not like those were bad solutions, and some, in fact, are really great and even simpler than Kubernetes. But we're building platforms and solutions on top of Kubernetes almost exclusively because it's really well designed, it's really well thought out. But at the end of the day, it's a platform for building solutions. So if you're a small development team trying to address your business's problems, that's not really something you want to have to care about. So what's wrong with Kubernetes? Nothing at all, right? But it's a context thing. I was talking to a friend of mine the other day trying to sell him managed Kubernetes. So he's not only like not wanting to leave Kubernetes, he doesn't want to leave his own self-managed Kubernetes clusters that he deploys just on EC2. He's happy there. And frankly, cool, like it works for them. This does work. But if you're a development-focused team, especially if you're just coming to the cloud or you have a new greenfield project, serverless just makes more sense. Serverless is this black box, and we're able to just use it. If we lean into this abstraction, right, of letting the platform take control, then we basically get to write application code against a well-defined interface, which looks a whole lot like what it used to look like writing code like on an operating system, right? We've kind of gone through this cycle where we have all these different things going on, and as a developer, you're now expected to implement your own proc structure and inject it into the kernel scheduler and be like, there, cool. Because that's effectively what writing YAML and passing it to Kubernetes is, right? Maybe you don't want to do that. And maybe you do. I enjoy it's fun, right? But I'm not an app developer. I mean, I just write highly scalable Hello World applications, really. I do DevRel, so. But, if you don't want to dig into that stuff, the complex systems concerns, right? That's something that you can push off to your vendor. And we don't seem to have a problem pushing off racking and network performance and other things to our vendors, so this is a logical thing to follow. So if we can accept the platform, then let's talk about what we run on it. Right, so functions, ideally they're small, easy to reason about little pieces of code. They're implemented to work together. So my friend Chad Aramora likes to say, loosely coupled, well-intentioned software. Idempotency we use to maintain sanity, right? So this is a simple thing. It's just, it's hard to implement at scale, but simply put, any service you're running, any function, whatever, try and make it idempotent, and you're going to have a much easier time deploying at scale, right? And idempotent just means, for anybody in the room who's not clear, it just means it's going to behave the same way, invocation after invocation. So this makes sense, right? When you pass off to the platform the idea of retries, right? You let the system do that for you. You got to make sure that your software is not going to shoot itself in the foot. So this all sounds familiar, right? This is all stuff that we've been talking about for a while. So Uncle Bob, or Robert Martin, wrote this or participated in this, agile authoring and wrote this passage, the single responsibility principle. This is from 2003. This is like really very simple rule of the road, right? So it's powerful, it's to the point. Really, like this is advice that's hard to ignore, right? Give each piece of software its own functionality. Make sure it's not doing more than that. And if other pieces of software are treading on its toes, make that stop. That's basically it, right? So write software to do a thing and write other software to do other things. And don't collide, right? So a single responsibility. So this is like in 2003. So why did, we've been using computers for like 45 years or something by then. Like, why did it take so long? And in fact, it didn't. So Doug McElroy in the UNIX Philosophy in 1978 laid down a bunch of knowledge about building system software. Make each program do one thing well. He also went on here to say that programs should work together and should expect to interoperate with programs in the future that don't yet exist, and that software should be written to fail early and loudly. So these are all principles we all embrace today. It's not news, right? So where'd this break down, right? If this guy and this team was talking about this in the late 70s, and then Uncle Bob starts talking about it in the early 2000s, and we're still writing 4,000 line functions, right? What happened? 4,000 line microservices. So how do we get there, right? And in my opinion, it's because we've never had a system that enforces like that good programming practices. So back when I worked on drivers, I had to fix a bug in a driver that was on deprecated hardware, but this customer was still running it. So luckily, it's the only interaction I had with it. But it was 40,000 lines of code in a single source module. And very few functions, and the functions that were there were like thousands of lines long and did a ton of different things. And it was just laced with go-tos, and it was just hot garbage. It was a terrible piece of software. And this was first committed to disk 15 years after the UNIX philosophy, because nobody said you can't do that, right? So that's where serverless is sort of getting this right, because it's both a platform and an architecture. So we can define this architecture and say, this is how this code should look. And then, yeah, there's nobody that's going to stop you from writing a 3,000 line function and running it in serverless, but there's a chance that the platform is going to penalize you. And the kind of like penalty that you want, right? It's sort of like your lint warning saying, hey, don't write code like that. So you have like runtime, run length limitations, and you have memory restrictions in serverless as the platform, right? And so that can actually help keep you in the swim lanes of like what we think of as good software practice. And like honestly, this is one of the really great things about it, because even with microservices, it takes a lot of effort to make sure that everybody's on the same team and trying to write the same intentioned kind of designed software. Serverless really kind of enforces it. Not violently, but somewhat. It enforces it. You can't run things for very long. You can't have a ton of memory. So what are some of the big ideas in the code? So we start small and compose solutions from these small things. Don't own what you don't have to. That's a really good rule. Plan ahead for observability, and think ahead to migration costs. I just want to run through some of these, hopefully, and be a little entertaining. So SaaS is kind of amazing. And I work at Oracle, so I'm not talking about like HCM or ERP, though those things are amazing too. I'm sure, especially for the people that use them. I just don't know anything about them. Like I can't speak to it. So when I think SaaS, I think, well, Google Docs, okay, fine. But I really think like Spotify or Twilio. Like these are services, right, that can do a thing really well. So if I want to write an application that streams media, it's really, really easy to do using these services. So the idea is to use those as much as possible. You don't have to go create your own media streaming service. You can use theirs. And then, looking to your own platform, to your vendor, right? Where if you are an Oracle customer, Oracle Cloud customer, you have Oracle Functions in your console, and you also have streaming and database as a service, and all of our storage, and all of our networks, and all this stuff that's just stacked right next to it. That stuff's there to use. And anybody who's an AWS user knows that they have there's like 85 logos, right? It's like you can do everything. So the idea here with serverless is to not reinvent those wheels. As much as possible, don't own what you don't have to. Choose a pattern in your code that helps you minimize, right? Because you're going to be thankful later when actually things run smoothly and the platform doesn't slap your wrist. Has anybody ever seen like containers or code that looks like this? Where it's just like you have all of the features and they're shoved in there just like we used to do with monoliths? Like that's not the idea, right? So break things down. So proliferation is much better than decompensating because of complexity. And observability and triage become infinitely easier at the boundaries if you have things that are smaller, right? So if you have a piece of code that does 8 things and you know where you started and you know where you ended, that's all you know. If you break that down into each individual step, now you can see where you enter and exit and you have meaningful spans and you can actually triage issues that way. This is about planning ahead a little bit. And that goes for the application estate too. So as you start planning out the software that you want to write, try to keep things simple. You can actually have some logical boundaries around things, like maybe a department has one application and another department has another application. But also there's functionality of the application and the events it's consuming. The things that it integrates with may be really obvious application boundaries that you can use. Sharing libraries between functions and applications is best done outside the execution context, right? So use libraries, use the packaging system for your runtime of choice. So what are some of the challenges that we have here after we accept the platform and after we say, okay, this is sort of a familiar development pattern, let's dig into it? It's not as simple as just jumping in and saying, okay, it's just going to be exactly like it's been, right? Whether that's on-prem development or if it's container and Kubernetes, there are some changes. And we have already established that certain things are table stakes. CI/CD, observability, configuration management. Like we know how to do these things and we're not going to leave them behind, right? And all of these things are available, and it's not as hard as it seems if you lean into this abstraction and you think to using services that you don't own, right? If there's something out there that does the job well, lean on it. So for tooling and pipelines, so as we've moved from like these bespoke compute environments, we've also moved from bespoke CI/CD environments and pipelines. So has anybody ever deployed their own Jenkins instance, written like 1,000 bash scripts? Yeah, me too. Yeah, multiple of us, right? All here. Yeah, right. So there's a few of you. It can be painful. Everybody else in the room, I assume you're using some managed service. Yeah, okay, I know. It's not that painful, but it's painful if it's not your day job, right? So managed services here are very common, and they all support in some way or another, these workflows that you need in serverless. So vendors will fill in the blanks for you, and especially if you have a vendor that's partnered with your cloud provider, right? So if they can actually peek in and say, okay, well, you're using a managed database instance, and I can actually also pay attention to that because we have tooling, because we're partnered, that's a really good thing. So configuration management. So we have established best practices here as well, and these are largely unchanged. So again, you can lean on managed services, and a lot of times, like your platform will actually have solutions for this. So AWS Lambda is a really good example of like, looking at a full breadth of all the configuration management, like kind of depths that you'd want to dig into, starting with like sensible defaults and going all the way down. So yeah, we're working on something in this space as well in OCI, and I think just everybody will have this. But beyond that, of course, you still have third-party sort of experts that can help even more. The idea here with serverless, beyond leveraging things that we already know and using tools, is doing as much at deployment time as you can. So one of the things that we see sometimes is like, I'm just going to use the cheapest compute instance I can. I'm just going to use the cheapest Lambda I can. I'm just going to use the cheapest function. And we only gauge by memory, right? So if you have a certain amount of memory and then you up that, you actually probably will get a little bit more compute and a little bit more storage and a little bit more network. I mean, depending on the platform. So I'm not making promises, but typically how that goes is the more memory, the more other stuff too. So if it's cheaper to have less memory, but you can run your workload 5 times as fast, right? You have some work to do there. So always, run POCs, run tests, and see what the best way to deploy is. So brownfield adoption is, I think, a huge opportunity in this space. So we have a lot of people that are looking to their on-prem monoliths and saying, I've got to get to the cloud. And they're saying, now let's buy some books on Kubernetes, and let's buy these things, and the architecture of the microservices and all that. You have to do some of that work, like we said, right? You have to break it down. But coming into Kubernetes, for example, as a solution, you're going to have to break everything down, containerize all of it, learn Kubernetes, build a cluster, and deploy. And even if you use a managed cluster, right, you still have to do that work. And that can be challenging if it's not your day job. And so with serverless, you're going to have to break down the monolith, but you can go kind of straight into production with it. And there are even solutions out there for sort of interposing with an API gateway. So you can actually have like your monolith behind, running in a VM behind an API gateway, and then start carving off routes and just implement those as serverless functions, right? So that's pretty amazing. We've never really had that before. And of course now if we think back, we could say, we could do that with Kubernetes too. And you can, but it's not integrated into any managed platform that I know of. Security is a thing that often comes up as well. And like my flippant answer is, well, that's our problem to solve, right? We keep you secure. That falls woefully short of what I wish would, So it's amazing what people do when they stop thinking about the complexities of systems. Let me say that. Like pushing API signing keys to GitHub is like the least of it. You're kind of working on something with a managed storage product, and it's like, it's just not working. And if I flip all the permissions to world readable, that works. Okay, well, no, it doesn't. I can't write to it. Oh, sure, world writable too. Great, ship it. No, don't do that, right? But that's what happens when you're running really fast and you're not super paying attention to the implications of the levers and the knobs that you're twisting and the levers you're throwing. So pay attention, and you're probably going to be okay, right? Best practices need to be established sort of for your organization, for your team. You decide how to be secure and how to be safe. The internet is a big, scary place. So, and then of course we're cloud providers, right? So we have all sorts of features in that space too, like WAF, and you guys know how that all works. So. Observability is a big issue, and there's thankfully a lot of solutions here. This is a fairly well understood problem. So back when I was working on OpenStack for a while, I would go to OpenStack summits and I would go to Startup Row, and almost every single startup, like 70% of them, were like Swift object storage startups, because it was the hardest problem to solve in that stack. If you go to KubeCon, almost all of the startups are around observability, right? It is a hard problem to solve. And the same goes for all cloud computing, in my opinion. So the good news is that there's a lot of people that really understand this well, both at your cloud providers and at third parties. Observability, for anybody who hasn't spent too much time thinking about it, is really like 3 things. We use metrics, which are an aggregate of how a thing performs over time. Tracing, which is sort of a full traversal of the stack for a given instance. And logging, which is like our breadcrumbs as developers, what we leave behind. We're writing code and we say, that might actually time out, let's put a log here. Okay. So triaging issues, a monolith and a VM is pretty straightforward, right? Something is slow, quote unquote. Like what does slow mean, right? The network's choked up, somebody stepped on a cable, it's CPU bound. So you log in and you look, right? Attach a debugger if you have to. We don't really do that in Kubernetes anymore. So we have things like Istio and Jaeger and Prometheus and Grafana and Falco and all these really cool open source projects that solve these problems really well. But those, of course, are, once again, all moving parts that you have to learn and love. So serverless can be challenging because the logging is there. We all log stuff for you and say, yeah, there's your logs. But even worse than microservices, like you get a log every invocation with a function. So hit an endpoint 1,000,000 times and you get 1,000,000 logs. Hit an endpoint 1,000,000 times a week, and boy, that really adds up. So it's pretty difficult to kind of find a needle in a haystack there. So you need integrated solutions. And like I said before, it's great to find solutions which partner with your cloud provider, right? And of course, your cloud provider has solutions. So in OCI, we have logging and monitoring. AWS has CloudWatch. There's Stackdriver. Sorry if I'm not mentioning your favorite one, but like everybody has solutions in this space. And they're all apparently getting better like every day, right? Like there's just tons of new features. So it is possible to triage things. Just plan ahead and make sure that when it's time to triage something, you have the data you need. So I'm getting near the end. I'm about to wrap up, and I've left this one till late. So I don't know if anybody follows this sort of space on Twitter, but this has been a very common debate lately. People really very much like to beat up on the notion of vendor lock-in. Now, I've been coming at this saying, well, of course vendor lock-in's a real thing. I am from Gen X, and I remember what IBM and Microsoft did, right? And both of those companies have done amazing things to change, not their image, who they are, right? And Oracle, we're doing a lot of work and still have a brand problem, I think, but we're working on it really hard. Because that's the direction we're going in, right? So when we say vendor lock-in, that's like a real thing that we should all be concerned about. And I think the thing is that people are thinking about vendor lock-in and serverless and saying, but there's nothing to be concerned about. And actually, they're kind of right. This is sort of like Apple products. If you use Apple products, right? If you get Apple Care and you like drop your phone, I can replace that glass. Like I have the little screwdrivers and really goofy glasses I wear, and I can do that. But I don't have to. Like Apple just sends me a new phone, right? Which is really cool. So sometimes vendor lock-in is actually not punitive. And also there's sort of another thing around like kind of being in a space and using a stack or a platform is that you get to know it really well, right? And so maybe it's not so bad. So, but you have to think about it. But it's not okay to say vendor lock-in isn't real, because it is definitely real. And I think, you know, Sam Newman, and actually at GOTO a couple years ago or a year ago, but he's also said this for a long time. He talks about the cost of migration. So don't think about vendor lock-in, especially since it's such a hot button word that some people will just dismiss. Think about the cost of migration. So if you have this running somewhere and you put X amount of data in there and you were charged for ingress, how much does it cost to move it out? Are you aware right now how much your data costs to put in someplace, and now how much they might charge you to take it out? You might be surprised, right? Some platforms will actually charge you more for egress, considerably more, maybe. So those are the types of things you have to think about. Also, if something is sort of lost to the void, or it just gets so like programmatically tied to a platform and that platform starts to not be the best in class and you need to move, what does it cost in horsepower to rebuild it, right? So cost isn't just monetary, it's also in people cost and time cost. So that's, to me, what I think about with vendor lock-in now in cloud. It's not so much like, oh, don't get in bed with that company. It's not that. It's think ahead to the future and what the migration costs are. And then you'll know if it's okay to stay put where you are or if you should start spreading the love. Which brings us to everybody else's favorite punching bag right now, MultiCloud. And I have seen people really railing against this. This is a myth, this is false, this dilutes your buying power, right? That's actually a real thing, right? So if you're in, I was in systems for years. We won the UNIX wars at Sun, right? We didn't do that by saying, hey, use whatever solution works for you. No, we said single throat to choke, use our disks, our systems, our OS, our everything. Here's a shirt, here's a car, whatever, like Sun everything. So now we're flipping over and saying MultiCloud's the way to go. Not really. What we're saying when we say multi-cloud is something you should consider is that serverless is really about using the best-in-class something. So like I said before, Spotify is really good at streaming music. They have a whole database of it. You can even work out a deal where you can play pieces of it for free. You don't have to go rebuild that. So Oracle is the #1 SaaS provider. There's also Salesforce. There's a number of vendors that you can actually work with. Don't go build your own solution if we have one for you, right? And so multi-cloud starts making a little more sense in that respect. And then as a platform, right, where you're writing and running your code, find the one that works best for you. And if you have a really big scale application that's using a ton of services from one vendor, build that application there. If you're married to another vendor's serverless platform, and then you start using all these services over here, you don't really need to use the internet to make API calls in that case, right? So this is just a place to think about and sort of make it less religious, if possible. Really think about what you have to deploy and what you want to build. So is serverless simpler? Does anybody think serverless is simpler? Right, so it's not usually. There's a lot more moving parts. And depending on what you're coming from, right? I mean, it could be simpler, but typically it's not. Serverless doesn't mean less complexity and may in fact mean more. But the type of complexity is something that I would rather you have, especially the developers in the room, and people building hands-on solutions for their companies in DevOps. The complexity in this case is almost always tied to your code and the services you're deploying, right? So I don't want you worrying about the complexity of like why a load balancer isn't working, right? So if you can focus where you're spending time burning complexity down, and if it's directly related to your business, you're better off. Is serverless better? Right, this is it's also a religious question. But you know, really what serverless promises is less toil, right? Less time focusing on systems problems, less time focusing on infrastructure problems. And your OpEx reduction can be really profound. It can be really significant. We have seen, you know, accounts where they're running sort of even running microservices in Kubernetes, and they're, you know, $10,000, $15,000 a month, and they move that solution to serverless, running almost the same exact code, and it goes down to $2 or $3 a month. Real numbers, like that's not, I know, like that's, I had a slide in here that was like, I don't believe you, but it's really true. It's kind of amazing. That does not come for free. That part is, it's tangible and it's real, but it's not free. Are we at time?
Yeah, we're over time now. So.
Oh, we're over time. Oh, I didn't know. Nobody actually told me. Okay, so final thoughts. Right, so I'm done. So put serverless on your radar if it's not already there, right? Greenfield, brownfield, migrations, whatever you're doing, take a look at it. Resist the urge to compare DevOps to serverless, because I think it's just a waste of time. And it is not uncommon for a proof of concept to actually be production ready. So go build stuff and see what you can build. All right. Thank you.